Hi everyone. So for this video, we're going to discuss conditions of equilibrium. Let's start. Let us recall how we draw the free body diagram. Because this type of diagram, we're able to observe only the forces that we wanted to observe. Sa pamamagitan nito, ay mas madali natin maintindihan kung ano ng mga puwersa na kailangan nating pagtuunan ng pansin para malaman natin ang state of equilibrium. So, itong ating example na palayo ay may iba't ibang puwersang maaaring nakapaloob. Pero ang titingnan lang natin dito ay yung gusto natin maobserbahan. So, yung palayok na ito ay mayroong tension at force due to gravity. So, sa ganitong paraan natin i-drawing or i-drawing ang free body diagram. The can of this corned beef has forces. We have normal force and the gravitational force. So, we already discussed last time during the first quarter the net force. The net force is simply the force that causes an object to move. So ito ang puwersa na magpapagalaw sa kahit na anong bagay. We can also call this net force as an unbalanced force. So if we go back to Newton's first law, an object at rest will remain at rest. An object in motion will remain in constant motion along a straight line path unless acted upon by a net external force. So, ibig sabihin, ang net external force maaaring magpabago sa motion or state of motion ng isang bagay. Tulad ng example natin na ito, ang pagkompreso. So, ang net external force ay manggagaling sa tsinelas. Sa tsinelas, nanggagaling ang net external force na magpapagalaw sa isang bagay na nakatigil. Ang ibig sabihin niyan ay gagalaw ang bagay sa pamamagitan ng net external force. Sabi ni Newton sa kanyang law of inertia, if a body at rest will remain at rest unless acted upon by a net external force. So kung walang net external force, walang bagay na hindi gagalaw. So, ibig sabihin, ang isang bagay nito ay nasa static equilibrium. Ano ang static equilibrium? Himay-himayin natin. Static means rest. Sabihin, hindi gumagalaw. When we say equilibrium, it is on a state of balance. Static equilibrium is state or a condition which all forces acting on a certain body are balanced, causing the object to remain motionless. Kaya pag sinabi natin, if a body is on a static equilibrium, the body is balanced and at rest. Merong tatlong states of equilibrium. Isa-isahin natin. Meron tayong tinatawag na stable equilibrium. It is the state of an object where the center of gravity is at the lowest position. Ibig sabihin, pag sinabing stable equilibrium, balance, the balance and at rest on a maximum position. When we say neutral equilibrium, it is on the state of an object where the center of gravity is neither lowered or raised. So maaaring gumalaw ang isang bagay or maaaring hindi gumalaw ang isang bagay kung ito ay nasa neutral equilibrium. Ang panghuli naman ay ang unstable equilibrium kung saan ang center of gravity ay nasa mataas na posisyon at may posibilidad na gumalaw kahit hindi ito hinahawakan. Anong ibig kong sabihin? Yung unang picture sa kaliwa, this one, is on a stable equilibrium. Meaning, that the center of gravity is on the lowest position, giving this shape or giving this whole object on a state of static equilibrium, balance, and at rest. Kung merong external net force, ay hindi siya gaano magbabago ng posisyon. Ngunit itong neutral equilibrium, mapapansin natin na kung ito ay itutulak ng isang pwersa, maaari itong gumalaw ng mas mabilis kumpara sa stable or ang object na nasa stable equilibrium. The last one is the unstable equilibrium. Mapapansin natin, the center of gravity is on the highest position. Ibig sabihin, maaari itong gumalaw kahit walang net external force na magpapagalaw dito. May mga factors na pwedeng makaapekto sa equilibrium. Ito ay ang mga number 1, location of center of gravity. Saan nakalagay ang center of gravity? Kung babalikan natin ang example kanina, mas mababa ang center of gravity, mas nasa state of equilibrium ito. Kaya stable ang isang bagay. Halimbawa, meron akong sports car at regular car. Bakit mas stable ang sports car kaysa sa regular car pagdating sa isang racing? Dahil ang center of gravity ng isang sports car ay mababa, malapit sa lupa, kumpara sa isang regular na kotse na medyo mas mataas ang center of gravity, na kaya kapag sa isang racing ay maaaring tumumba ang isang regular na kotse sa biglang pagliko. Number 2, area of the base of an object. The greater the area of the base, the more stable it is. Halimbawa, may isang lalaki at isang babae sa loob ng jeep. Upo sila ng magkaharap. Walang ibang tao maliban sa kanilang dalawa. Kung papansinin natin, ang lalaki ay nasa malaking bulto ng pangangatawan, mala Johnny Bravo. Si Johnny Bravo ay merong itsurang inverted triangle. Ibig sabihin, mas malaki ang kanyang braso, kanyang balikat, kumpara sa kanyang baywang at balakang. Ito ay nagbibigay ng mas makipot na area sa kanyang base kung ito ay nakaupo. Kaya ang gagawin ni Johnny Bravo ay bumukaka upang magkaroon ng wider or mas malawak na base, upang siya ay magkaroon ng isang stable or maging stable sa kanyang pagkakaupo. Yung babae naman ay isang balingkinitang babae na tawagin nating Betty Boop. Malaki ang balakang, maliit ang kanyang braso at ang kanyang mga balikat. Kung titingnan natin ang kanyang geometric figure, siya ay mayroong erected triangle or nakatayong triangulo. Sa ganitong paraan or sa ganitong itsura ay makikita natin na ang ang erected triangle ay may mas malaking base. So hindi niya kailangan pang bumukaka or kumapit kung biglang huminto ang jeep. Dahil may mas malakas siyang base or may mas malawak siyang base ng area ng base, ay mas stable ang babaeng may ganitong figura. Kaya dapat sa mga lalaki ay humawak at bumukaka ng bahagya upang magkaroon ng mas malaking area ang kanilang base kung ito ay uupo sa jeep. Next, the mass of an object. The heavier the object, the more stable it is. Ibig sabihin, mas mabigat ka, mas stable ka. Mas magaan ka, less ang pagiging stable mo. Mas mabilis kang or mas madali kang matutumba kumpara sa may mas mabibigat na pangangatawan. Halimbawa, which is more stable? Yung pulang base o yung puting base? Kayo na ang bahalang sumagot. Isa pa. Yung kaliwang truck o yung truck o yung golf caddy o yung sasakyan sa golf. Panghuli, yung malaking mamang sumo wrestler o yung maliit na batang sumo wrestler. Which of the following is now stable? So, tingnan natin ang sagot. Dito, ang mas stable ay yung may pulang base. Bakit? Dahil ang kanyang area ay mas malapad kumpara sa area ng puting base. Pangalawa, anong mas stable? Siyempre, yung mas mabigat o yung mas malapad. Yun ay ang truck. Ang panghuli, ang mas stable ay yung mamang malaki ang pangangatawan ng isang sumo wrestler. Let's move on to our discussion. Concurrent forces are forces whose line of action meet at a common point. Balikan natin yung una nating example na palayo. So we have here the tensional force and the force due to gravity. These two forces are called concurrent forces because they meet at a common point, doon sa gitna. Non-concurrent forces are those forces whose line of action doesn't meet at a common point. Halimbawa, yung tumbang preso. Yung tsinelas na isang external force na nagpagalaw sa plata, hindi natin maituturing na concurrent forces ang net external force na yun dahil hindi nasa isang lugar nag-meet ang mga pwersang ito. Resultant forces, on the other hand, is a single force which acting alone. Ibig sabihin, ito ay yung pinagsamang mga pwersa na nag-isa or nagiging isa sa pamamagitan ng pag-add natin ng mga pwersang ito. This can be obtained by using a vector addition as written on this equation. So all the resultant forces along the x-axis and along the y-axis. If we have this kind of equation, if we are going to use this equation, then we are going to look into the first condition of equilibrium. The first condition of equilibrium just stated to us that the sum of all forces acting along the x-axis and the y-axis must be equal to 0 for a body to be at rest in a static equilibrium. Ibig sabihin, para ma-achieve natin ang first condition, equilibrium, para ma-achieve natin itong first condition of equilibrium, ay kailangan ay lahat ng pwersa ay maging equal to 0. Sabi natin, di ba? Static equilibrium or static equilibrium should have rest and balance. Sa pamamagitan nito, when we say balance, all forces acting along the x-axis and along the y-axis must be equal to 0. Let's have example. A boy climbing a tree by means of a rope. The weight of the boy is 50 newtons. Find the tension in the rope. So, sagutan natin. So, from the example that we have given, the weight of the boy is equal to 500 newtons. At ang kailangan nating malaman ay kung ano daw ang value ng tensional force. So, i-drawing natin. Kung ito ang puno at merong isang bata, sorry, hindi ako magaling mag-drawing. At may isang bata na nakasabit sa lubid. Ano daw ang tensional force dito? What is T? Kung ang bata ay mayroong weight na equal to 500 newtons. Sabi natin, to meet the first condition of equilibrium, all forces acting along the x-axis must be equal to 0. All forces acting along the y-axis must be equal to 0 as well. So, tingnan natin. Meron bang force acting along the x-axis sa drawing na ito? Wala. So, ang meron lang na forces acting ay nasa y-axis. So, ibig sabihin, lahat ng pwersa na nasa y-axis ay meron tayong tension plus weight. And these two must be equal to 0. Now, to identify the tension, lilipat natin sa kabila si weight. So we have tension must be equal to negative W. Now, we have the tension is equal now to negative 500. So we have negative 500 newtons. Sir, bakit po negative yung 500? Let's take note. We have here that the weight is on the downward direction, making that the value of the weight should be negative, following the direction of the force. So that's why when we substituted W or the weight, we place it negative 500. So a negative multiplied to a negative, the tension now becomes positive. So the tensional force present on the rope as the boy climbs on it is equal to 500 newtons. So let's have example number 2. Find the tension in the rope that holds the signboard. So we have here the signboard with a weight of 30 newtons, and we have an angle on each tension cords or tension wires with a 60-degree angle. So we want to identify how much force is present on this tension 1 and how much force is present on this second rope. Then let's take note that this signboard here is called as the equilibrant force or the balancing force that makes these two tension balance or in a state of equilibrium. Let's try to answer this. So we have here the weight. So our weight is equal to negative 30 newtons. So alam na natin na siya ay negative dahil the weight is moving downward. So we have both theta 1 and theta 2. The angle 1 and angle 2 both equal to 60 degrees. Then let's take note that we said that all forces acting that all sorry this is sigma. So all forces acting on x must be equal to 0. So and all forces acting on the y must be equal to 0 as well. So let us draw a Cartesian diagram for our uh, for our this is the Cartesian diagram for our tension. It's for our force diagram. So we have here the first one. So we have this first tension, membrane pictures. Take note that they are concurrent forces. For example, we have A. And then we have the last one. Since they are forces, they should be represented by others since they are vectors. Okay, so we now have this. Let's take note that this is T1. This is T2. And then, so this is your T1 sub Y. This is T1 sub Y. And here is your T1 sub X. Here, this is your T1 at T2, sorry. T2 sub Y. And this is your T2 sub X. Both of these angles are equal in value. So this is your theta 1. This is your theta 2. So please take note of this drawing. So to identify T2x, so we need to use cosine theta since the angle it lies on the x-axis. So to get T2y, we need to use sine theta. While for T1x, still cosine theta, and T1y is sine theta. So we have our last given the equilibrium for the weight. So here we will now calculate first for forces acting along x. So we stated now here. So we have T1x. So we have T1x on the x-axis plus T2x. So since T2x lies on the negative side, we will put it here negative. So minus T2x. Do we have a x component for the weight? So we don't have. And we will not put it anymore. Then this equal to 0. So again, to identify the x component, we will use x component, this T1x here. We will use cosine theta. So we have now T1 cosine, T1 cosine theta minus T2 cosine theta is equal to 0. Since we wanted to identify either T1 or T2, we can move T2 to the other side. So we can come up now with T1 cosine theta is now equal to T2 cosine theta. So we divide, since angle here is both 60, so we can divide both sides by cosine 60, cosine 60 or cosine theta. So you will notice that this will cancel each other because cosine 60, because cosine 60 is 0.5, 6.5. That's 0.5, 0.5 divided by 0.5, so that's 0. 0.5 divided by 0.5, sorry, that's 1, so 1. So we have T1 now is equal to T2. So we're going to use this to our next component, the y component. Let's just take next page. So to identify the components or the forces acting on the y-axis, we have T1y plus T2y. Since the weight is moving downward, so we will put minus W, which is equal to 0. So we can now put W to the other side so that we can come up at T1y plus T2y is equal to W. So we have T1 sine theta plus T2 sine theta is equal now to W. Let's take note, since we place the weight on the other side, the value becomes positive. So we now have 30 newtons. Let's take note, in our first said that T1 is equal to T2. So we can substitute, since T1 is equal to T2, then we substitute T1 to T2. So we can change now here. So this becomes T2 sine theta plus T2 sine theta is equal to 30 newtons. Now, to simplify, we have 2 T2 sine theta is equal to 30 newtons. We want to identify T2, that's the missing value, missing variable. So this becomes, we divide both sides by 2 sine theta, 2 sine theta. This cancels. So we now have T2 is equal to 30 divided by 2 sine 60. So this now becomes T2. So we have 30. We have 30 divided by 2 sine 60. So we have 17.32. We have 17.32, which is in newtons. So that's the value now of T2. To get the value of T1, we now get the value of T1 since T1 is equal to T2. Therefore, T1 is equal to 17 point. We have 17.32 newtons. Okay. So to check whether our answer is correct, so again, we look into our calculator. So we stated that T1 sine theta plus T2 sine theta must be equal to 30 newtons. So this one. So we have T1 is 17.32 sine theta, sine 60 plus 17.32 sine 60. So you notice we have 29.999. So roughly it's equal to 30 newtons because we did not copied all the 17.320 something. But if we're going to do that, let's check. We have 30 divided by 2 sine 60. So that's 17.3205080759. So that's answer. Sine 60 plus answer sine 60. So you'll notice it's 30. The answer here in the calculator is this 17.3205080759. So sine 60 plus the answer, sine 60, then we get 30 newtons. So our answer here is correct. So we have to go back. So we have torque. Sorry. So we're done with this. So we have a torque is a quantity that measures how effectively a force causes a body to rotate. It is produced when force is applied with leverage. It is defined as the product of the force and the lever arm. So the torque can be calculated through this equation. We have torque, which is in Greek letter tau. So we symbolize torque in this form. Then we have R. R is our lever arm or the radius. And then the force is F. Then we have sine theta. Why do we have sine theta here? So we're going to notice if the force is parallel to the radius, then there will be no rotation that will take place. As if we just going to push something and it will not move. But if we have the force at an angle 90 degrees or perpendicular to the radius, therefore we are able to make a maximum rotation. If we're going to notice on this equation, the greater, if we have a 90 degrees uh, pushing, this will become equal to 1. Sine 90 is equal to 1. So we have a maximum value for the rotation, which is the maximum value for the torque. So we have example number 1. 125 newtons is applied to a nut by a wrench. So this is the nut and this is the wrench. So the wrench has a length of 0.300 meters. So from this position up to this position. So that's the radius. And we're going to apply the force on this point, making the radius and the force perpendicular to one another. Since they are perpendicular, sine 90 is 1. So we have FR, so that's 125 newtons times 0.300 meters, giving us a torque equal to 37.5 Newton meter. Let's take note that Newton meter here, or the torque here, is not a form of work done or an energy, and this Newton meter that the torque has a unit is not equal to joules. Then we have next example. If you push on the door as shown in the drawing, what is the torque? Let's take note that most of our door knobs are placed at the far end of the door so that we are able to push this easily compared if we are going to place it on the middle or near the hinge. Because the shorter the radius, the lesser the torque and the more force that you need to have. Let's take note that the radius and the force is inversely proportional to one another. So since we are going to push this door with 330 newtons of force at 55-degree angle, we will multiply it to the radius. So the torque now is equal to 410 Newton meter. What happens if there are two or more torques acting or act on an object at the same time? So two forces are applied to the object. The object is free to rotate about the spin axis. And both of these causes a torque. So if F1 on this diagram here causes torque, and this causes torque as well, F2, if F1 causes a counterclockwise rotation around the x-axis, around the axis, then F2 causes a clockwise rotation around the axis. So here, this may cause the object to move from this point, moving to this point. So that's counterclockwise. while this one will make the object spin this way. That's clockwise. If a torque causes a counterclockwise rotation, it is positive. So again, from right to left, that's counterclockwise, then that's positive. If the torque will move from, um, if the torque causes a clockwise rotation, then it is negative. The sum of two torques would be TF, yeah, TF, sorry, tau 1 plus tau 2, or just F1 R1 plus F2 R2. So we'll just combine these two. So when that happens, it will not move because both of them are causing motion. So diba, pag itong isa ay papunta dito, yung isa naman ay papunta sa kabila. So this is counterclockwise, diba? Yung isa naman clockwise. This is counter. Isa naman clockwise. So nagka-cancel each other. Kaya ang tawag na natin doon ay second condition of equilibrium. It is when the total net torque or the net torque about any axis is equal to 0. This condition states that if an object is in an angular equilibrium, sometimes called as rotational equilibrium, then it is either at rest or else it is rotating with a constant angular speed. So let's have this example number 3. Okay. Two metal orbs are attached to a very lightweight rigid wire. They are suspended from a rigid point on the overhead as shown. So this is this. We have here a specific point which we attach these two rigid bodies. The system does not move, so they are not moving at all. Then we calculate the distance from the suspension line to the center of the gravity of the right sphere. So we want to identify what will be the radius between this body to the center. If the left body or the left object weighs 1 kilogram and it is 45 centimeters from the center, then what will be the distance or the radius of this 4 kilogram object from the center? From here, we have a force that is moving upward, and then we have forces moving downward. So we have a greater force on this and a lesser force on this one. So we have M1 GR1 and M2 GR2. Since we want to identify R2. So let's try to calculate. So we have now that the total torque must be equal to 0. So we have torque 1 plus torque 2, which is equal to 0. Since based on the drawing, torque 1 is on the left side, we will subtract it to torque number 2. Why? Because if you're going to draw it again, this object will move on clockwise direction, and this will move on a counter clockwise direction. Sorry, clockwise. This will move clockwise because mas mabigat siya. And then this one will move counter clockwise. So, halimbawa, because ito ay pababa. So, that's counter clockwise. So, this is positive. This is negative. So, here, we will make this negative. Okay. So, we now, to substitute, we have M1 GR1 minus M2 GR2. So we want to identify only R2. To do that, we will put this to the other side. Right? So we now have M1 GR1 equal to M2 GR2. So we divide both sides by M2G, M2G. So we now have R is equal now, R2 is equal now to M1 GR1 divided by M2G. Since G here, we can cancel it out. So R2 is equal now to M1 R1 over M2. So R2 is equal to M1 is 1 kilogram. R1 is 0.45 meters per meter, and then 4.0 kilogram. Okay, so both kilograms will be cancelled out. So R2 is equal now to so we have 1 times 0.45 and then divided by 4.0. So we have R2 is equal to 0.11 meters. So this is how far the second object from the center, or this is 11 centimeters. Since it is 45 centimeters from the center. So we have on this example that the total torque must be equal to 0. So we have torque 1 minus torque 2 is equal to 0 because torque 1 is moving counterclockwise and torque 2 is moving clockwise in the clockwise direction. That is why torque 1 is positive and torque 2 is negative. So we'll substitute this, come up with this equation. M1 GR1 minus M2 GR2 is equal to 0. Since we want to identify R2, we will move this variables for quantities to the other side. So we now have M1 GR1 is equal to M2 GR2. Then to isolate R2, we divide both sides by M2G. So M2G here will cancel out. And then we may have R2 is equal to M1 G R1 divided by M2G. Since we can cancel G here because they have the same value, then we can come up with a working equation R2 is equal to M1 R1 M2. So 1 kilogram times 0.45 meter divided by 4.0 kilograms. Both units of kilograms will cancel out. Then we have an answer of 0.11 meter or 11 centimeters. So this is how far the object from the center. So okay, that's it for our discussions for the conditions of equilibrium. If you have questions, I will answer it on our synchronous session. Thank you and God bless.